Hey there, beautiful people. So in this video, as I said in the first combined gas law video, is I'm just going to do some example problems involving the combined gas law, and then we're going to work through those so you can see them in a variety of situations. So in each of these videos, I'm going to do three examples, one involving P and V, one involving V and T, and one involving P and T. So if, like I always say, you understand what's going on or you think you understand what's going on, just pause the video and then you can do the problem on your own and then come back to see how I solved it. So let's get going. Okay, let's start by reminding ourselves what the combined gas law is. So that I'm going to just write up in the corner. P1 V1 over T1 equals P2 V2 over T2. Okay, so we've got our first set of conditions on one side, our second set of conditions on the other side. And anything we don't need, we're just going to cross out or ignore. So a sample of CO2 gas has a pressure of 5.65 atmospheres in 125 milliliters. So that's our P1. This is our V1 because it's milliliters. The sample is transferred to a new flask where it has a pressure of 6.99. So that's our second P2, at the same temperature. What is the volume of the new flask? That is going to be our V2. So I plug it into my formula. I've got 5.65 atmospheres times 125 milliliters. The temperature stays the same from start to finish, so I don't need to include temperature in this problem. Now I'm going to transfer over, and the other side I have 6.99, and I have V2. So I'm obviously going to divide both sides by 6.99, and I'm going to solve for V2. So I'm going to pull out my handy dandy calculator. Okay, so I have my handy dandy calculator, and I'm going to plug in my numbers. So I've got parentheses, 5.65 times 125 divided by 6.99, enter. 101 point blah, 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 blah. So 101 is what I'm going to keep to in my answer, and my answer is going to be in milliliters. Why is it going to be in milliliters? Because my V1 is in milliliters. If my V1 was in liters, then my answer would be in liters. Now, how did I know I needed three digits? You will notice that in the P1, it's 1, 2, 3 digits. In V1, it is 1, 2, 3 digits. And in P2, it's 1, 2, 3 digits as well. So I round my answer to 3 digits. Okay. So that was example one. Let's go on to example two. Okay, gas law example two. So combined gas law number two in this video. When 5 liters of carbon monoxide at a temperature of 50 degrees Celsius is transferred to a 2.5 liter flask, the temperature decreases. What is the temperature at this new volume? So I have a V1, I have a T1, and I have a V2 because it's transferred to a new flask. So clearly it says what is the temperature? That is going to be my T2. So I plug it into my formula. Again, my formula is P1 V1 over T1 equals P2 V2 over T2. So I've got 5.0 liters. I have no pressures, so I'm going to ignore that. So my pressure is canceled out in this particular video. In the previous one, it was temperature. I've got 50 degrees Celsius, but I know that I have to add 273 to get myself to kelvins because I always kelvins. Okay, always kelvins. So I'm going to be transferring it to a 2.5 liter flask, and I'm solving for T2. So I'm going to cross multiply like that. So I will have 5.0 times T2 equals 2.5 times 50 plus 273. I know that I wrote 272 here. I'm going to change that. I don't know why I did that to 273. I'm going to divide both sides by 5.0. I'm going to pull out my handy dandy calculator and I'm going to solve. So I've got 2.5 times, oh, didn't mean to do it that way. There we go, parentheses, 50 plus 273 divided by 5, and I get 161.5. So my T2 equals 161.5. But as I look back onto my numbers, I can see I've got 2 digits and 2 digits and 2 digits. So therefore, I have to round my answer to 2 digits. So this answer would become 160 kelvins. Now, do I have to change it to degrees Celsius? No, I do not. The question does not ask for degrees Celsius, so don't do more work than you need to. Okay, let's go to example number 3. Okay, so in this video, it says Alex is given a helium-filled balloon when he goes to Chuck E. Cheese's. When he goes outside, he starts crying because the balloon shrinks. If the balloon started at a pressure of 1 atmosphere, that's my first pressure, P1, and 20 degrees Celsius, T1, and the temperature outside is 5 degrees Celsius, T2, what is the pressure in the balloon? P2. Okay, so again, remind myself of my formula. P1 V1 over T1 equals P2 V2 over T2. I can see that I have no volumes, so therefore volumes are going to cancel out, and it's just going to be P's and T's. So I have 1.0 divided by 20 plus 273 equals P2, because that's what I'm solving for, and 5 plus 273. I cross multiply, and I get, so this is going to be 20 plus 273, P2, equals 1 times 5 plus 273. I'm going to divide both sides by 20 plus 273. And again, as I've said before, if you want to solve that temperature and just plug in 293, please feel free. No one is stopping you from doing that. Go ahead, have at it. I'm going to pull out my handy dandy calculator and I'm going to plug everything in. So I've got 278 divided by 293, and I get 0.9488. But I check my nut digits. 1, 2, 1, 2, and 1. Well, 1 is kind of too small of a number to round to, so I'm going to do it 2 digits. So I'm going to do this as 0.95 ATM because your units are atmospheres, because it says it right there. Okay, and that's 3 examples involving the combined gas law. And now you should be an expert in combined gas law. But if you're not and you're still unsure, go watch my next video and I'll have a couple more examples in there for you. Have a great day.